Good morning, students. In today's class, we shall be solving some questions from NCERT Exercise 5.5. While solving questions on differentiation, we have majorly focused on identification of function first and then using a suitable method to differentiate that function. So in today's class, we shall be studying a new kind of a function. So suppose we have a function of this kind, this way, a function defined as px to the power qx. So for differentiating this kind of a function, the method that we use is the logarithmic differentiation. For example, we may have a function like base is x and the power can be sin x. It can be base log x and the power is cos x. It can also be log of x square plus 1 and the power of the function is suppose sin 2x, this way. So these are various kinds of functions of this kind. So what we note here is that the base of a function is a function of x, the power is also a function of x. In such case, the method that is used is the logarithmic differentiation. So we'll understand how to differentiate using the log functions. So here we are required to use some properties of the log function. So since for differentiation we have base e, so if we have log of pq, then it can be simplified as log p plus log q. Likewise, log p upon q can be written as log p minus log q. Log a to the power m can be written as m log a. So these are basically the three properties of the log function that we shall be using for differentiation. So from this exercise, let us start here with the third question. So we are starting here with exercise 5.5. Third question. It is log x to the power x. Let's call this function y. So first we identify it is log x to the power cos x. So logarithmic differentiation is possible, and let us take log on both sides. So left side is log y and on the right side it is log x power cos x. Now here, before we differentiate, we have to ensure that the function on the right hand side is in the simplest form. So if we compare the given function on the right side with the third result here, then using the third result, the function can be simplified as cos x, which is same as m into log a, so that is log a is log x. So here we have now product of two functions, cos x, log x. So the moment we get product of two functions, that means the right hand side is in the simplest form, and hence we differentiate with respect to x. So differentiating left side with respect to x, we get 1 upon y. This is a composite function, so into dy by dx. On the right side, let us use the product rule. So cos x into derivative of log x plus log x into derivative of cos x. So here this again is a composite function, so differentiating the log function first, we get 1 upon log x. Once again differentiating the log function, we get 1 upon x. Over here log x into minus sine x. This is minus sine x. So here is 1 upon y, which on the right side can be written as dy by dx is equal to y into the right hand side expression, which is cos x upon x log x minus sin x into log x. So here we are going to replace y. We know y is this function. So log x to the power cos x into the terms in the bracket. So here normally we notice that on using logarithmic differentiation, the derivative that we obtain is usually quite a big expression. Like you can see here, a big expression is obtained. So this way we use the identify function first, that it's a special kind of a function. Then we take log on both sides, convert the right side function into a simple function, and then either we use chain rule or product rule or quotient rule, whichever is applicable, and differentiate to find out dy by dx. So the next question that I'm going to take up is question number 6. Y is equal to x plus 1 upon x to the power x plus x to the power 1 plus 1 by x. Okay. So here you notice that this is a function raised to another function plus a function raised to another function. So we have got two special functions on the right hand side, and these two special functions are being added. So when we add two special functions or when we subtract two special functions, we directly don't start with the taking log on both the sides. So what we'll do here is we'll name these functions on the right hand side. Let's call them u and v. And now when we differentiate with respect to x, we get du by dx plus dv by dx. So this is how we are going to find out dy by dx. We'll find out this derivative, then this derivative, substitute here, and hence we obtain dy by dx. So we will start with function u. So u is x plus 1 upon x to the power x. So here we take log on both sides, and we get log u is log x plus 1 upon x to the power x. Using properties of log, it becomes log x plus 1 upon x, and on the left side we have log u. So we'll differentiate with respect to x. So the left side will become 1 by u du by dx, and on the right side there is a function x and there is a composite function log x, composite log function. So using the product rule, we will get here, I'm writing down the product rule first, derivative of x into log of x plus 1 by x plus x into derivative of the log function, this way. So left side is 1 upon u du by dx. On the right side, derivative of x is 1. So the first term is log x plus 1 upon x, and the second term x, differentiating this we get 1 upon x plus 1 by x, and differentiating x plus 1 by x we get 1 minus 1 by x square. And now let us simplify this term, log x plus 1 by x. So here is positive x in denominator, taking LCM we get x square plus 1. Over here again taking LCM, x square minus 1 upon x square. So these x square terms cancel off, and we can write down du by dx is u times, so I'll write down u directly, which is x plus 1 upon x to the power x. So u into the derivative term which we have obtained, log x plus 1 by x, and the next term is x square minus 1 upon x square plus 1. So what is this? Du by dx, which we will later substitute here. Next step is to find out dv by dx. So we know what is v. We have assigned v as function x to the power 1 plus 1 by x. So once again, taking log on both sides because it is a special function, so we get log x to the power 1 plus 1 by x, which can be written as 1 plus 1 by x log x. On the left side we have log v. Now because here we have got an algebraic function and a log function, so we can product of two functions, so we can differentiate left side and the right side using product rule. So using the product rule we get this. Okay, and further simplifying, derivative of 1 is 0, derivative of 1 by x is minus 1 by x square into log x plus 1 plus 1 by x into derivative of log, which is 1 by x, and simplifying it further, what do we get? Minus log x upon x square, here x plus 1 upon x square. So dv by dx will be v times, v is this 1 plus 1 by x into this expression. So here x square, this is minus log x upon x square plus x plus 1 upon x square. So we have obtained dv by dx also. So once we have obtained du by dx and dv by dx, let's go back to the first step. Alright, because our ultimate aim is to find out dy by dx. So finally, what is dy by dx? Du by dx, so let's write down this expression. The term in the bracket is log x plus 1 by x plus x square minus 1 upon x square plus 1 plus dv by dx, which is this minus log x upon x square plus x plus 1 upon x square. So this is the final answer. So you can see here, while we are differentiating, we are getting really big expressions, and differentiation will be possible only if we remember all the previous results. Next is question 8. Sin x power x plus sine inverse root x. This is function y. This is a special function raised to another function. This is not a special function, but we can't still take log function directly, so we'll write it down again as u plus v and differentiate. Dy by dx is du by dx plus dv by dx. So now let us find out these derivatives one by one, starting with u. U is sin x power x, a special function. So taking log on both sides, log sin x power x, using properties of log, this is x log sin x, and left side is log u. So here polynomial function, composite log function. Okay, so now we can differentiate both sides with respect to x. So here we are using product rule. So x dash into log sin x plus x into derivative of log sin x. So this is log sin x plus x, composite log function. So differentiating log function, we get 1 upon sin x. Differentiating sine, we get cos x. So what is du by dx that we obtain? That is u times, this is u, so u times this expression, which is log sin x plus x cot x. Okay, so du by dx obtained. Next, this is v here, so I'll solve it on this side. V is sine inverse root x. This is not a special function, so we are not taking log function, we are directly differentiating dv by dx. Now we know that derivative of the sine inverse function is 1 upon under root 1 minus x squared. This x is here. Okay, so following like that, this is a composite inverse function, so 1 upon under root of 1 minus root x square will be x. Because this is not x, so we are going to differentiate root x. So here we have under root 1 minus x, and this derivative is 2 root x, which can be combined as 1 upon 2 under root x into 1 minus x. So this way we have got dv by dx. So finally dy by dx is du by dx, which is this expression, log sin x plus x cot x, plus dv by dx, which is this 1 upon 2 under root x into 1 minus x. So the derivative of the function with respect to x is obtained. So next we'll try question number 11. It is x cos x power x plus x sin x power 1 by x, and this is equal to y. So there are two special functions, so u plus v and dy by dx will be du by dx plus dv by dx. So let's start with u. U is x cos x power x, special function, so taking log on both sides, log x cos x power x. So right side is x log x cos x. So one function is x, the other is a composite log function. So differentiating with respect to x. So here derivative of x into log x cos x plus x into derivative of log x cos x. So the product rule. The first term is log x cos x. Next term, this is a composite function, so differentiating log function, we get 1 upon x cos x. Then x cos x again has to be differentiated using product rule, because here is a polynomial and a trigonometric function. So right side is log x cos x, and this term here we can cancel x, so plus 1 upon cos x, and applying product rule here we get cos x minus x sin x. So finally what is du by dx? Du by dx is u times log x cos x, and here if we multiply the bracket by 1 by cos x, we get plus 1 minus x tan x. Replacing u is this expression x cos x power x into log x cos x plus 1 minus x tan x. So du by dx obtained. Next, so here see what is important. We have used product rule here once, alright, after this step, and again at this step we have used product rule. So the product rule has been used twice. Next, v function is x sin x power 1 by x, taking log on both sides. So we have here 1 upon x log x sin x. So here we have two functions, one by x and the other is a log function. So product rule applicable. So differentiating with respect to x, derivative of 1 by x into log x sin x plus 1 by x into derivative of log x sin x. So this derivative is minus 1 by x square log x sin x plus 1 upon x, composite function. So differentiating log function, we get 1 upon x sin x. This is again when we differentiate x sin x, we again have to use the product rule. So minus log x sin x upon x square plus 1 upon x square sin x into using product rule x cos x plus sin x. So we still can simplify it, or if I direct do it together, dv by dx is v, which is x sin x to the power 1 by x into this expression, where see you can write down in different ways. If you want to take this x square common, you can write it down here, okay, or you can simply multiply this term with these two terms, so the way you want to write it down. So I'm writing it like this, multiplying this expression. Here we get cot x upon x square plus 1 upon x square. So as I said, if you want, here is x actually. Okay, so had you wished, you could have taken x square common here. So finally we have got dv by dx also. Now the last step, dy by dx. So write down this expression plus this expression, that will give us dy by dx. So it's a big expression, ensure that all terms are written correctly. Log x cos x plus 1 minus x tan x. So that's du by dx. Next term is this, dv by dx. So x sin x power 1 by x into minus log x sin x upon x square plus cot x upon x plus 1 by x square. So this way we have obtained dy by dx. So next question that we shall try is question number 12. 12 equation is given. So the equation is x to the power y plus y to the power x is equal to 1. You can see sum of two special functions. Alright, so we know our usual notations. We'll write it down as u plus v is 1, and we'll differentiate with respect to x, du by dx plus dv by dx. On the right side it's 0. So let's find out du by dx. This is where we are going to substitute. Now dy by dx has not come into picture as yet, So we'll see how does it come into picture. Let's start with u. U is x to the power y, taking log on both sides, and using properties of log, we have y log x, differentiate with respect to x. So here we can use product rule. I'm directly writing it down. Derivative of y into log x plus y into derivative of log. So du by dx is u, which is x to the power y, log x dy by dx plus y by x. Okay, so here you can see we have dy by dx. So du by dx, this is what we'll substitute here. Next, let's find out here dv by dx. V is y to the power x, so taking log on both sides, log y power x. On the right side, using properties of log, x log y. Now differentiate both sides with respect to x. So on the right side, we are once again using product rule. So writing down the result directly, log y plus x, derivative of log function is this, and derivative of y is this. So dv by dx is v times this function, which is log y plus x upon y dy by dx. So here also you can see there is a term dy by dx. So du by dx and dv by dx is what we are going to substitute here. So let us substitute. Du by dx is x to the power y into log x dy by dx plus x to the power y minus 1 into y. Okay, and then the next term is dv by dx, which is y to the power x log y plus y to the power x minus 1 into x dy by dx, and the right side is 0. So I'll put here these terms in brackets just to distinguish that these are the two derivative terms. So look at the dy by dx terms, these two terms, x to the power y log x plus y to the power x minus 1 into x dy by dx. Okay, derivative terms, shifting these two terms to the right hand side, taking a minus sign common, we have y to the power x log y plus x to the power y minus 1 into y. So now here we can write down dy by dx as minus these terms in bracket upon this expression, which is x to the power y log x plus y to the power x minus y into x. So here you must have noticed that in the previous questions we were writing down some function and we were naming a function as y. Here we did not do so because y variable was already there in the question, and moreover the question is given in the form of an equation. Okay, so we have not used variable y. So the next question is question number 14. Cos x to the power y is equal to cos y to the power x. Left side is a special function, right side is a special function, so we can directly take log on both sides. So we get log cos x power y equal to log cos y power x, using properties of log, y log cos x equal to x log cos y. Now on either side you see it is product of two functions. So we are going to differentiate with respect to x using product rule. So I'll be writing down the product rule directly here. So dy by dx into log cos x plus y, derivative of log cos x, 1 upon cos x, and derivative of cos minus sin x. So product rule used in the left hand side. Now moving to the right hand side, it will be log cos y plus x, 1 upon cos y. Differentiating cos y, we get minus sin y, and there's a variable y, so differentiating again we get dy by dx. So look at the dy by dx terms, one is here and the other is here. So let's just simplify. Dy by dx into log cos x minus y tan x, on the right side log cos y minus x tan y dy by dx. So again bring these dy by dx terms on one side, so I'm shifting this term to the left hand side. So we shall get dy by dx into log cos x plus x tan y. This term is already on the right hand side. Bring this term to the right hand side plus y tan x. And now it is easy to obtain dy by dx. So dy by dx is log cos y plus y tan x upon log cos x plus x tan y. Next we will try out here question number 15, which is xy equal to e to the power x minus y. Now here you can see y variable is also there in the equation. This is one function raised to another function, so we can take log on both sides. Even if you don't want to use a log concept, you still can directly differentiate. So if you are using the log on both sides, log xy is equal to log e to the power x minus y. So here, using properties of log on the left side, we get log x plus log y on the right side, x minus y into log e, and we know log e is 1. So the expression in the simplest form is this. Now it's easy to differentiate. So derivative of log x, derivative of log y is this, derivative of x minus derivative of y. So derivative terms, 1 upon y plus 1 dy by dx equal to 1 minus 1 by x. So dy by dx is 1 minus 1 by x upon 1 plus 1 by y, which can also be written as x minus 1 this way. So this is finally dy by dx. Here we have taken log on both sides. Without taking log also, we could have differentiated this function. Now see, this exercise we are basically discussing special functions. Special function means a function which is raised to another function. But if a function is not a special function, but it's a complicated one, look-wise it is a complicated one, in that case we still can use a logarithmic differentiation. So let's use this concept in question number 1. The first question of the exercise is product of 3 terms, cos x, cos 2x, cos 3x. When you look at product of 3 terms, you can of course use the product rule, but here we want to use a log function. So how do we use the log function for differentiation? First of all, take log on both sides. So we have log y is equal to log cos x into cos 2x into cos 3x. So using properties of log on the right hand side, we can write down log cos x plus log cos 2x plus log cos 3x. The moment you look at this, now you know the differentiation is easy. So the next step, we'll differentiate. So these are all composite functions. So derivative of log function 1 upon cos and derivative of cos minus sin x. Here derivative of cos 1 upon cos 2x, derivative of log cos 2x is this. Then derivative of the cos function minus sin 2x, and then differentiating 2x also. So that 2 I'll write down here. Okay, moving on to the next term, derivative of log function, then derivative of cos function minus sin 3x, and the derivative of angle 3. So this way you can see on the right side we have minus tan x minus 2 tan 2x minus 3 tan 3x, which is 1 upon y dy by dx. So finally, what is dy by dx? dy by dx is y times, y means cos x, cos 2x, cos 3x. Y times this expression, so if we take a minus sign common, we have here tan x plus 2 tan 2x plus 3 tan 3x. So you can see here in just few steps we are able to find out the derivative. If we normally use the product rule here, maybe the number of steps are more. Okay, a similar kind of a question is second question. The expression given is square root of x minus 1 into x minus 2 upon x minus 3, x minus 4, x minus 5. This is function y. So here if we remove this radical sign, we know that this is raised to the power half, a function raised to constant. So this is now here a constant function, so we can use the log function here for easy differentiation. So taking log here, I'll do few steps directly. Log of the right side and simplified form will give us half log of this expression. And now let's differentiate 1 upon, oh no, we can't differentiate right now, so we have to simplify. So on the right side you can see it is something like log a upon b, so can be written as log a minus log b. Now also properties of log can be used. This is log ab, which can be written as log a plus log b. Minus sign here, so right now if we ignore minus sign, log abc can be written as log a plus log b plus log c, and then there's a minus sign, so all three terms become negative. Minus log x minus 3 minus log x minus 4 minus log x minus 5. So you have got 5 log terms, and now it is very easy to differentiate. 1 upon y dy by dx is half derivative 1 upon x minus 1. It's a composite function, but derivative of x minus 1 is 1. That applies to all cases. So I'll write down like this. Derivative done, differentiation is done. So what is dy by dx? Y by 2 into this expression. Now here we would prefer not to take LCM because it will still make the look of the function complicated. So we will leave it in this form. Here I have written directly y. If you want to write down this function, you may write down. So this is how a complicated function like this, using the log function and its properties, simplifies to a form where differentiation is easily possible.